In this lecture, we continue our study of PL/SQL by focusing on single-row functions and their role in customizing query output. Single-row functions allow us to manipulate and format data, making query results more meaningful and readable. They are widely used to perform operations on individual values, such as text processing, numeric calculations, and date formatting. In this part of the course, we will explore how to effectively use these functions to enhance the presentation and usability of data in SQL queries. This slide introduces the concept of implicit data type conversion in Oracle. Implicit conversion occurs when the Oracle database automatically converts one data type into another during expression evaluation. This happens without explicitly writing conversion functions such as toNumber or toDate. For example, Oracle can automatically convert character data types varchar2 or char into number or date types when required in an operation. While this feature simplifies query writing, it should be used carefully because implicit conversions may lead to unexpected results, errors, or performance issues. Therefore, it is generally recommended to use explicit conversions when precise control over data types is needed. This slide illustrates the concept of explicit data type conversion in Oracle. Explicit conversion is performed using specific built-in functions such as toNumber, toDate, and toChar. Unlike implicit conversion, here the developer manually controls how data is converted from one type to another. For example, toNumber converts character data into numeric values, toDate converts character data into date values, toChar converts numbers or dates into character format. This approach is more reliable because it eliminates ambiguity and reduces the risk of errors during execution. Overall, explicit conversion is considered a best practice, especially when working with different data types, as it ensures accuracy, readability, and better performance in SQL queries. This slide explains how to use the toChar function with date values in Oracle. The toChar function converts a date data type into a formatted character string, allowing you to control how the date is displayed. The syntax is toChar date format model. The format model defines the output structure of the date and has several important rules. It must be written in single quotation marks. It is case sensitive. It can include various date format elements such as year, month, day, etc. The FM modifier can be used to remove extra spaces or leading zeros. The format model is separated from the date value by a comma. Using toChar with dates is essential for customizing output formats, especially when presenting data in reports or user interfaces. This slide presents the main elements used in date format models for the toChar function in Oracle. These elements define how a date will be displayed as a string. YYY displays the full year in numeric form year, displays the year written in words in English. Shows the month as a two-digit number. Month displays the full name of the month. MON shows the abbreviated three-letter month name. DY displays the abbreviated day of the week. Day shows the full name of the day. DD displays the numeric day of the month. By combining these elements, you can create flexible and customized date formats depending on the requirements. Overall, format model elements allow precise control over how date values are presented in SQL output. This slide continues the discussion of date format model elements, focusing on additional formatting options. First, time elements allow you to format the time portion of a date. For example, hh24.mi.ssam displays hours, minutes, seconds, and the AM/PM indicator. Second, you can include custom text in the output by enclosing it in double quotation marks. For instance, DD of month produces results like 12 of October. Finally, number suffixes can be used to display numbers in a spelled-out form. For example, DDSPTH converts a numeric day into its textual ordinal form, such as 14th. Overall, these features provide greater flexibility in formatting dates, allowing you to create more readable and user-friendly output. This example demonstrates how the tu char function is used to convert a date value into a formatted string. In the query, the column hire date is transformed using tu char hire date fmdd month YYY. The format model defines how the date will appear. DD displays the day of the month, displays the full name of the month YYYY, displays the full year FM, fill mode, removes extra spaces that Oracle normally adds to month names. As a result, instead of the default date format, the output becomes more readable, for example, 17 June 1987. Additionally, the alias hire date is used to rename the formatted column in the result. Overall, the tochar function with a format model allows developers to control how dates are presented, making query results clearer and more user-friendly. This example shows how the tochar function can be used to convert a numeric value into a formatted string. In the query tochar salary 99,999 darn, the number salary is formatted according to the specified format model, Wung, adds a currency symbol 99,999, defines digit positions and includes a thousand separator, comma, gone 0, ensures that 2 digits are displayed after the decimal point. As a result, the numeric salary value is displayed in a more readable financial format. For example, $6,000 the alias. Salary is used to name the formatted output column. Overall, tu char for numbers is useful for presenting data in reports, especially when formatting currency, percentages, or aligned numeric outputs. This slide explains how to convert character data into numbers and dates using the tu number and toDate functions. The function toNumber char format model is used to convert a string into a numeric value. The format model specifies how the number is structured, for example, decimal separators or currency symbols. Similarly, toDate char format model is used to convert a string into a date value. The format model defines how the input string represents the date, e.g., day, month, year, order. These conversions are important because in many cases data is stored or received as text, but needs to be processed as numbers or dates. Additionally, the FX format exact modifier enforces strict matching between the input string and the format model. This means Oracle will only perform the conversion if the format exactly matches the specified pattern. Overall, these functions ensure accurate and controlled data type conversion DAOs, which is essential for correct query execution and data processing. The RR date format is used in Oracle to correctly interpret two-digit years, especially when working across different centuries. Unlike the YY format, which simply attaches the current century, the RR format uses logical rules based on the current year to determine the correct century. Key idea: RR helps avoid errors when interpreting years like 95 or 17, deciding whether they belong to the 1900s or 2000s. Rules of RR format: if the two-digit year is 0 to 49 and the current year ends in 0 to 49, same century, and the current year ends in 5099, next century. If the two-digit year is 5099 and the current year ends in 0 to 49, previous century, and the current year ends in 5099, same century. Example input 27 OCT 17 with RR interpreted as 2017 with YY may incorrectly become 1917 depending on current century. This example demonstrates how the RR date format ensures correct interpretation of two-digit years in queries. The condition toDate 1 Jan 90 demon RR uses the RR format to interpret the year 90 correctly as 1990, regardless of when the query is executed. The query selects employee last names, displays their hire dates in a readable format using tochar filters employees hired before 1990, key point using RR guarantees that the query returns consistent results over time. It works correctly whether executed in 1999, 2001, or today. If the YY format were used instead, Oracle might interpret 90 as 2090, leading to incorrect results. Nested functions in SQL allow one function to be used as an argument inside another function. This means that the result of one function becomes the input for the next, enabling more complex data transformations within a single expression. Single row functions can be nested to multiple levels without limitation. Oracle evaluates these nested functions starting from the innermost function and then moves outward step by step. First, the deepest function is executed and produces a result. Then this result is passed to the next function, which processes it further. Finally, the outermost function produces the final result. For example, in the expression F3, F2, F1, col arg1, arg2, arg3, the function F1 is executed first, then F2 uses the result of F1, and finally F3 processes the result of F2. This sequential evaluation ensures correct and predictable outcomes when combining multiple functions. Overall, nesting functions is a powerful technique that allows complex operations to be performed efficiently within a single SQL statement. This example demonstrates how nested functions are used together in a single SQL expression to transform data step by step. In the query, three functions are combined: substr, concat, and upper. Oracle evaluates them from the inside out. First, the function substar last name 18 extracts the first 8 characters of the employee's last name. Next, the result is passed to concat US, which adds the suffix US to the extracted string. Finally, the entire result is passed to upper, which converts all characters to uppercase. As a result, a name like Hunold becomes Hunold US, and Ernst becomes Ernst US. This example clearly shows how nested functions allow multiple transformations to be applied in a structured and efficient way within a single query. General functions such as NVL, NVL2, nullif, and coalesce are used to handle null values in SQL expressions. These functions are important because null represents missing or unknown data, which can affect calculations and query results. The NVL XPR1 XPR2 function replaces a null value in XPR1 with XPR2. It is commonly used to provide a default value when data is missing. The NVL2 XPR1 XPR2 XPR3 function checks whether XPR1 is null. If it is not null, it returns XPR2. Otherwise, it returns XPR3. This allows conditional logic based on the presence of data. The nullif XPR1 XPR2 function compares two expressions. If they are equal, it returns null, otherwise it returns XPR1. This is useful for avoiding errors such as division by 0. The coalesce XPR1 XPR2 XPRN function returns the first non-null value from a list of expressions. It is more flexible than NVL because it can handle multiple alternatives. Overall, these functions help ensure more reliable and meaningful query results by properly managing null values. The NVL function is used to replace a null value with a specified actual value. This is especially useful when working with incomplete data, ensuring that queries return meaningful results instead of null. The syntax is NVL XPR1 XPR2. If XPR1 is null, Oracle returns XPR2. Otherwise, it returns XPR1. NVL can be applied to different data types such as numbers, dates, and character strings. But an important rule is that both expressions must be of compatible data types. For example, NVL commission PCT 0 replaces missing commission values with 0 NVL hire date 01 Jan 97, replaces missing dates with a default date NVL job ID no job yet, replaces null text with a meaningful message. Overall, NVL helps improve data readability and prevents issues in calculations or output caused by null values. This example demonstrates how the NVL function is used in calculations to handle null values and ensure correct results. In the query, NVL commission PCT 0 replaces any null commission values with 0. This is important because if a column contains null Any arithmetic operation involving it would also return null. The second part of the query calculates the annual salary and sal using the formula salary 12 plus salary 12 NVL commission PCT 0. Here, NVL ensures that employees who do not have a commission still receive a correct annual salary calculation instead of getting a null result. For example, if commission PCT is null, it is treated as 0, so the calculation becomes simply the base annual salary. If commission exists, it is properly included in the total. Overall, NVL is essential in such cases to avoid null propagation in calculations and to produce accurate and complete results. This example demonstrates how the NVL2 function is used to apply conditional logic based on whether a value is null or not. The syntax is NVL2 XPR1, XPR2, XPR3. If XPR1 is not null, Oracle returns XPR2. If XPR1 is null, Oracle returns XPR3. In the query NVL2 commission PCT, salpscom, sale, Oracle checks the value of commission PCT. If an employee has a commission not null, the result is salpscom. If the commission is null, the result is sal. This creates a new column, income, that clearly indicates whether the employee's income includes commission or only salary. Overall, NVL2 is useful when you need a simple if-else logic in SQL, allowing you to produce different results depending on the presence of data. This example demonstrates how the nullif function is used to compare two expressions and return a result based on their equality. The syntax is nullif xpr1, xpr2. If xpr1 is equal to xpr2, the function returns null. Otherwise, it returns xpr1. In this query, the lengths of the first name and last name are calculated using the length function. The result of length first name is labeled as xpr1, and the result of length last name is labeled as xpr2. The expression nullif length first name, length last name compares these two values. If the lengths are the same, the result becomes null. If they are different, the function returns the length of the first name. This allows us to easily identify cases where the lengths match, since those rows will produce null in the result column. Overall, nullif is useful for simplifying comparisons and handling cases where equal values should be treated as missing or ignored in further processing. This example explains how the coalesce function works and why it is more flexible than NVL. The syntax is coalesce xpr1, xpr2, xprn. Coalesce returns the first non-null value from the list of expressions. Oracle evaluates the expressions from left to right and stops as soon as it finds a value that is not null. Unlike NVL, which works with only two arguments, coalesce can handle multiple alternative values. This makes it especially useful when you want to check several columns or fallback options in a single expression. For example, if the first expression is not null, it is immediately returned. If it is null, Oracle checks the next expression and continues this process until a non-null value is found. Overall, coalesce provides a concise and efficient way to handle multiple possible null values and ensures that a meaningful result is returned whenever possible. This example shows how the coalesce function is used to select the first available non-null value from multiple columns. In the query coalesce manager ID commission PCTE1, Oracle checks the expressions in order. First, it looks at manager ID. If it is not null, that value is returned. If manager ID is null, Oracle checks commission PCT. If both values are null, the function returns 1 as a default value. As a result, the column com always contains a value. It shows the manager ID if available, otherwise the commission, and if neither exists, it displays 1. This approach ensures that missing data is handled efficiently and avoids null values in the result. It also demonstrates how coalesce can combine multiple fallback options in a single expression, making queries more robust and readable. Conditional expressions in SQL allow you to implement if-then-else logic directly inside a query, making it possible to return different results based on specific conditions. Instead of writing procedural code, SQL provides built-in constructs that evaluate conditions and produce corresponding outputs within select statements. There are two main approaches. The case expression is more flexible and readable, supporting complex logical conditions and multiple branches. It is the modern and preferred method for implementing conditional logic. The decode function is an older Oracle-specific feature that performs simple comparisons. It works similarly to a switch case structure but is less powerful than case and mainly used for equality checks. Overall, conditional expressions help make queries more dynamic and intelligent by allowing data to be interpreted and transformed based on defined conditions. The case expression is used in SQL to implement conditional logic similar to if-then-else statements. It evaluates conditions sequentially and returns a result based on the first condition that is true. If none of the conditions are satisfied, the optional else part is executed. The general structure is case when condition, then result when condition, then result. Else default result and Oracle processes the case expression from top to bottom. As soon as a condition is met, the corresponding result is returned and the remaining conditions are not evaluated. Case expressions are widely used in select statements to transform data, categorize values, or apply business logic directly within queries. Overall, the case expression is a powerful and flexible tool for creating dynamic and readable SQL queries. This example demonstrates how to use the case expression to implement conditional logic directly within a SQL query, similar to an if-then-else structure. The query selects last name, job-id, salary, and calculates a new column called revised salary. The value of this column depends on the employee's job ID. The logic works as follows. If job ID, it prog, the salary is increased by 10%, 1.10. Salary, if job ID, st clerk, the increase is 15%, 1.15. Salary, if job ID, SRF, the increase is 20%, 120. Salary for all other job roles. The original salary is returned, else salary. The case expression evaluates conditions in order and returns the first matching result. From the output we can see, for ITPROG, salary 4200 becomes 4620 for st clerk. Salary 3500 becomes 4025 for other jobs, e.g. AC account. The salary remains unchanged. In summary, case is a powerful tool for applying business logic such as bonuses, adjustments, or classifications directly within SQL queries without using PL SQL. This slide introduces the decode function, which is another way to implement conditional logic directly in SQL. The decode function works similarly to a case expression or an if-then-else statement, but it uses a more compact, Oracle-specific syntax. It compares a given expression with a list of possible values and returns the corresponding result when a match is found. The general syntax is decode, expression, search 1, result, search 2, result, default. Here is how it works. The function evaluates the expression and compares it with each search value one by one if a match is found. It returns the corresponding result if no match is found. It returns the default value if provided, otherwise null. For example, decode can be used to transform or categorize data directly in a query, such as mapping job IDs to salary adjustments or labels. However, compared to case, decode is more limited because it only supports equality comparisons, no complex conditions like etc. That's why in modern SQL, case is generally preferred, but decode is still widely used in Oracle for simple conditional transformations. This example shows how to use the decode function to apply conditional logic directly in a SQL query. The query selects last name, job ID, salary, and calculates a new column called revised salary using decode. The function checks the value of job ID and returns a modified salary depending on the match. The logic is the following. If job ID, it prog, the salary is increased by 10%. 1.10. Salary if job id, chi, st clerk. The increase is 15%. 1.15. Salary if job id, chi, say rep. The increase is 20%. 1 to 20. Salary if none of these values match. The original salary is returned. Salary as default. Decode compares job id with each specified value and returns the corresponding result when a match is found. From the result table, we can see employees with IT prog have increased salaries. Employees with ST clerk and say rep also receive adjusted salaries. Other employees, e.g. AC account, keep their original salary. This example demonstrates that decode can be used as an alternative to case for simple equality-based conditions. However, unlike case, it cannot handle complex logical expressions, which makes case more flexible in modern SQL. Thank you for listening.